Ellie Dillard filming another Vodcast, and today we're going to be learning about mathematical expectation or expected value. Okay, so first of all, what is mathematical expectation or expected value? It is the long-term average of a repeated event or an expected outcome. Okay, so we're going to look at this first example here, where x equals your grade in stats class, and p of x is the probability of earning x grade in stats class. So we have x, and you can get either a 0, 1, 2, a 3, or a 4, 0 being the worst grade and 4 being the best grade. And then we have the probability of x. So the probability of getting a 0 in the class is 10%, the probability of getting a 1 in the class is 15%, the probability of getting a 2 in the class is 15%, the probability of getting a 3 in the class is 40%, and the probability of getting a 4 in the class is 20%. So to calculate the mathematical expectation or the expected value, we can use this handy equation right here. So this E stands for expected value. That's what we're calculating. So we calculate it by multiplying each event by its corresponding probability. So x is each event, and this is the corresponding probability. And then we find the sum of them. That's what this sigma notation here means. It basically just means add everything together. And I like to put parentheses around here just so I can keep that clear in my head that we're going to add all of those things together. So we're going to look at x and its corresponding probability. So we're going to look at 0 and 1, 1 and 15, 2 and 15, 3 and 40, 4 and 20. So what we have to do is we have to multiply each of them together, and then we just add them all together. So we're going to do 0 times 0.1 plus 1 times 0.15 plus 2 times 1.15 plus 3 times 0.4 plus 4 times 0.2. And when you add all of those up, you should get 2.45. So what 2.45 means is that it's the expected grade that you would get if you just signed up for this class. But you might be thinking that nobody actually got a 2.45, so how could that be the expected grade that you would receive? And it's just because it's the average of all of the grades. So, for example, if 4 people took a test and 3 got 100% and 1 got 0%, the average of these 4 tests would be 75%, even though no one actually received a 75%, if that makes sense. Okay, we're going to go on to another example. Okay, so the scenario is that we have a weighted die where the 6 comes up 3 times as often as any other number. So it's a weighted die, which means that one number is going to show up more often than the others. So that means that the 6 is going to come up 3 times as often as any other number. And we can look at that by, so we have all of these probabilities of rolling each number. So if we add all of those up, we do 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 plus 3/8 equals 8/8 equals 1 equals 100%. So that's just to show you how that would look on a die. Okay, so just to play the game, you spend $3 just to play. If you roll a 1, 2, or a 3, you get $5, so you make $2 in profit. if you roll a 4 or a 5, you get $3, so you just get all of your money back. And if you roll a 6, then you get no money, so you lose $3. Okay, so X is the result of one roll, so you can get a 1, 2, 3, 4, 5, or 6. And then the probability of X is the probability of rolling each result, each number. Okay, and then M is just the profit, kind of like what I just talked about. So I'm going to have you guys calculate the profit, M, for this bottom row here, and then, so pause this video, come back, and hopefully we got the same profit. Okay, you should have gotten these profits. So if you roll a 1, you'll make $2. If you roll a 2, you'll make $2. If you roll a 3, you'll make $2. If you roll a 4, you'll get your money back. If you roll a 5, you'll get your money back. And if you roll a 6, then you'll lose $3. Okay. So now, using this handy equation right here, I want you guys to find the expected value, the expected profit that you would make using the probability of X and the profit. Okay, pause this video, come back. Okay, hopefully your work looks something like this. You should have done 2 times 1/8 plus 2 times 1/8 plus 2 times 1/8 plus 0 times 1/8 plus 0 times 1/8 plus negative 3 times 3/8, which should equal about negative 0.375 or negative 38 cents, because you can't have half of a penny. That would be kind of hard. Okay, so what does that negative 38 cents mean exactly? What that means is that it's the expected value of this game, so it's the long run average. So a person will never lose 38 cents in one game, but over many plays they will lose on average about 38 cents each time they play. Okay, thank you guys so much. I hope you learned a little bit about mathematical expectation.